Welcome to Ask and Learn.
All right, guys, we're doing problem 38 of chapter 18 in Chemistry Central Science. So phosphorus is present in seawater to the extent of 0.07 ppm by mass. Assuming that the phosphorus is present as dihydrogen and phosphate, H2PO4-, calculate the corresponding molar concentration of H2PO4 in water. So remember what our ppm formula is. ppm is equal to mass of solute, or let me just write this as gram solute per gram solution times 10 to the 6. So our phosphorus is going to be 0.07 ppm, and to just make it simple, we can put 0.07 ppm is 0.07 grams of phosphorus per 10 to the 6 grams of H2O. Times 10 to the 6, the 10 to the 6 is canceled out, so that leaves us with mass of phosphorus being 0.07 grams. Now, if we know the mass of phosphorus is 0.07 grams, then we can get an idea of how much of our other substances we have. So let's convert phosphorus to moles. 0.07 grams times the molecular weight of phosphorus, that is 31 grams per mole, so 1 mole over 31 grams. So 0.07 divided by 31. That's going to be 2.22 2.2, or rather 2.3 times 10 to the negative third moles. Now let's look at the structure of H2PO4. So we have H2PO4. So we have 0.07 gram. We effectively have 0.07 grams of phosphorus in 10 to the 6 grams of H2O. So we can find the mass of the. So we can find the number of moles of the other components by doing this, because we can look at the molar. We can find the molar ratio. So there are two. So let me write this as moles of P. So the ratio of hydrogen to phosphorus, that's 2 to 1. So that means that we're going to have, as we're going to double this, we're going to have 4.62 moles, 6x times 10 to negative third moles of hydrogen. And for phosphorus, it's 4 to 1. So we're going to multiply 2.3 times 10 negative third moles times 4. And then we're going to get 9.2 times 10 to the negative 3 moles of oxygen. So now we're going to combine these. And that's no, we're not going to combine these that I just added an unnecessary step. I just realized that. So since if we look at our H2PO4, that the ratio of molecules of H2PO4 will be equivalent to the number of phosphorus. So the number of moles we have of H2PO4, is going to be equal to that of our phosphorus. Yes. H2PO4 or now they want us to find the molar concentration of H2PO4 in seawater. So we're assuming we have 10 to the 6 grams of water. So we have to convert that to liters. And water has 1,000, density of water is 1,000 grams per liter. So 10 to the 6 grams. So 10 to the 6 grams times 1,000 grams per liter equals 10 to the third liters. So now to find a molar concentration, remember M is equal to N over V, where N is volume in liters. So we're going to divide this 2.3 times 10 to the negative third moles over 10 to the third liters. So M is going to be 2.3 times 10 to the negative 6 molar. So remember, the key to answering this question is we don't need to get any specific value for our water. It can be an arbitrary value that we assign. I just choose 10 to the 6 because it's a lot easier. Then we convert our mass into moles, and we look at the molar ratio. So we have this many amounts. So we have 1 H2PO4 for every for 1 mole of phosphorus. So these have an equivalent molar ratio. We can and then we just take this and divide it by the volume to get our concentration. This part is probably the trickiest because you just have to understand the molar ratio. You have to understand that for every oxygen, phosphorus, hydrogen, whatever atom you're looking at, you are going to have a specific number of molecules, and that's very important to understanding this problem. It can be a bit esoteric, but you get better at this with practice.